Hello, there is Impossible Creations and welcome in Procedural Generation Grid tutorial. In this video we will prepare some simple layout, generate simple paths between the rooms, then I will show some aspects of the pathfind based generating, then show how you can prepare field setup for generating stairs, and finish with different approach for generating paths between rooms. Okay, let's start. First I will open Planner window and dock it on the left. Right now we will prepare a layout with which it will be easier to demonstrate the pathfind based generating. Let's create a build planner preset and call it first example. Let's add first field and call it main room. Let's hit send here to open its window and dock it on the right. It will be room with square shape with origin center. Oh, let's reset the scene view. Okay. And now we will quickly spawn different fields around this one. So let's add other rooms. Let's select it. And it will be random size rectangle with origin in center. For start, let's put here like 5 instances of this field. Right, they're generated here. Now let's place them around the main room. I will open the graph in a second window so we can focus on it. Okay. And we will use angle direction node to place rooms around the main room per like 50 degrees. And to do this we need to define steps like 0, 50, 100, 150, etc. So let's use iteration index node, multiply it by 50. And connect it to the angle input. As a result we have a direction vector, and let's multiply it by value 3 to push rooms by 3 cells. Let's finally apply the position by setFieldPosition node. And let's check how it looks. Okay, offset is too small, so let's go with 4. In a while we will add some collision avoidance nodes, but first a quick tip, just to remind. If you would generate field setups with different cell size, the position will not be adjusted to the scale until you check the cell size toggle here, and now it's synchronized. The second approach would be using the cell size multiply node. Another thing we will notice here are these floating point offsets, causing fields to not be aligned with the cells. You can see it clearly in the orthographic view. And we can quickly solve it by toggling run to scale. And now they are aligned. Now let's implement some collision avoidance. And to make algorithm work correctly, we need to call it after all rooms are set up on a layout. And to do this we will use the secondary graph. It will be called after all first procedures. So after each room is set up on a layout like this. If we call the avoidance node in first procedures, so when a room is setting its position and immediately checking the collision with all others, when all other rooms are not yet set up on a layout, then checking collision with them would be useless and it can cause some inconsistency in the layout. So let's do it correctly with a secondary graph with default execution mode, which will be called after first procedures but before post procedures. Let's use bound separate push node, which by default is checking collision with all fields. And as you see, it pushed away the fields which are overlapping. But we also want to push fields which are stitching to the main room. So let's increase size of the volume just a bit. And it's working, but the rooms are pushed away a bit too much, so let's change the push distance multiplier. And now it seems to be more stable. If you need better clarity, then you can run the step debug mode and follow the process step by step. Alright, now I will increase number of rooms to 7 and let's generate paths. So when all rooms are placed in their final position, we can generate the paths with relevant collision. So let's go to post procedures and add pathfind generate node. There we can use where path should start. So there we start on self. We want to find path towards the main room, which index is 0. And we want path to avoid collision with other rooms, so let's collect all of them. Let's get all instances. Alright, now let's join the generated path shape with our field. And there we have it. With step debug you can follow the process again, also with some gizmos for the pathfinding algorithm. But I guess you would like to make corridors look different than the rooms it goes from. And to solve it we will use another field planner. And we could use the join shape cells node to join the path shape with the other field planner, but I will show you different approach. Let's disable path generating for the other rooms. Add new field planner for paths. I will disable initial shape for it, since it will be generated dynamically. Okay, let's go to post procedures. And let's again call path generating for each room towards main room. To do this we will need to iterate through every instance of a room. So let's use iterate fields loop node. Let's get instances of field of index 1, so other rooms. Then we are executing the pathfinding algorithm one by one on each room, searching towards the main room, again colliding with each room on the layout, and joining the resulting path with this field. And there we have it. Now let's generate guides for doorways, so let's expand this node, and there we have outputs for the connection cells. Let's use add counter cell instructions node, just like in previous tutorials. And there we have doorway guides for room start cell and path start. Now let's generate doorways for connection between the target room and path end. So let's use another counter cell instructions node. And there we have it. For more details about the doorway instructions, check other tutorials. Now this layout is generating just with a little bit of randomization, but it's just a simple example. You can add more randomization on your own. Now let's quickly check this build plan on the build planner executor. I will use one of the demo field setups. Use the same one. Let's generate preview. It seems right, so let's generate modules. And everything seems to work correctly. Now let's focus on different aspects of the pathfind node. To show it clearly, I will create another build planner preset. Let's call it second example. Let's add first planner and clear preview. Let's just simply call it room A. And let's create another room, call it room B. Let's place it on the layout a bit further from the room A. Maybe somewhere in here. And now let's generate path between these two rooms with another field. Let's call it path. Let's disable initial shape since it will be generated dynamically. Add pathfinding node. Search from room A towards room B and connect the shape. And here's the result. But let's say we want an obstacle between these two rooms. So let's add another field. I will call it obstacle and move it in an order higher so the colors are changing. Now path is yellow. Now let's define the shape and position for the obstacle. We will make it very long and place it between the two rooms. Now path will be generated ignoring collision with an obstacle since we not set it up yet. So let's assign the index of the obstacle field, and in result we get elevated path. That's because default pathfind settings are 3D. Now I will make the obstacle taller, and you will notice something interesting. So pathfind algorithm chose the way below the obstacle. You can use pathfind algorithm not just for the corridors, but also for pipe systems, for the vents, or a lot of different things. So it needs a lot of customization settings. Let's say we don't want to use the 3D pathfinding, we want to make it flat. So let's open pathfind setup, and there we can define which directions should be possible for the pathfind algorithm to use. And since we not set it up our directions, it's using default 3D search. So now let's add our custom right, left, forward and back directions. As you can see below, each direction can contain its own rules, cost for the pathfinding algorithm, and we will cover it in a while. But don't bother with it now. Let's see the result without up and down directions, and there we have it. So if you start making some field setups and you need just 2D search, you can quickly open this pathfind setup and hit the 2D flat preset, and there you have it. Alright, now let's go back to the 3D search problem. If we still want a path to be searched in 3D, but we don't want to path go below the ground, we can make down direction to cost more, or we can define some limits for the pathfind. Let's set here 0, so algorithm is not allowed to go in position below 0. But now if we can go up and down, it seems that this path is not the best one. Why? That's because the 3D direction presets are coming with some extra settings for the up and down directions, which are adjusted to support the stairs setups. But in this example setup, we want to use the default settings, so let's remove down and up directions and let's add them again with the default direction settings. Alright, now it reacted the way we were hoping it for. And you can use structure like this for elevators, for ladders, for ventilation systems or other custom ideas. But it's not good for the stairs. To generate path which is adjusted for the field setups which want to generate stairs, we need to set it up differently. And to show it for you a bit clearer, I will change the setup. We'll move the room B a bit further. I will move obstacle also a bit further, okay, and make it a bit smaller. Alright. And now we need to set some advanced rules for the up and down directions for the pathfinding algorithm. And first rule will be forcing the direction to change just after it's used for generating next path step. So when path goes up, it can't use again up direction, so it will use left, right, forward or back. And then again it can use the up direction. And in the result we have stairs-like shape. Alright, now let's switch to a bit different example. I will disable the obstacle field and move room B a bit higher. And there, maximum customization possibilities takes its voice again. Sometimes you will like to start path with the room ceiling, but not in this case. To solve this, we have another rule for the pathfind direction. Let's open pathfind setup, and there we have parameter allow use since path step. Now the algorithm will be allowed to use up direction only if there are some steps already. I recommend checking tooltips of every parameter in a pathfind setup window, The pathfind-based generation is a pretty complex subject, and I will not explain all features of this node in this video, but I'm focusing here on the most important elements of this algorithm. Now there is pretty important parameter. It's enabled by default. It's forcing algorithm to find the targeted height position for the path as soon as possible. If we not do this, first algorithm will go flat beneath the room and then start searching for the way up, and after that it will try to find another variations for the path and who's the most efficient one. Alright, it found path like this, and you can notice that the path ends in the floor of a target room. And you can use it to implement some floor hatch in a field setup, but in this case we just want to connect it like with a DOS. So we need to disallow the algorithm to finish path with the up direction. But now I got a console log which tells that pathfinding exceeded its search step count limit. That happened because the algorithm have much harder task to find a way towards target room with the rules we just set it up. So let's just increase the limit to allow algorithm searching for the path a bit longer. And it succeeded. If pathfinding takes too long or the path is not found, it can be handled with some extra settings. But still I recommend to keep prioritize target while level enabled, since it makes the work for the pathfind algorithm much easier. Now we will go to another part of this tutorial video and we will focus on a field setup which implements the stairs rules. Okay, let's dock the field designer window. I will create the simplest field and I will call it stairs setup. Let's add modifier with spawner for a floor to see something. Dock the mod window. Use the prefab. Just spawn it. I will assign tag floor. Okay, and now let's add another modifier, and this one will be for the stairs. I will find the prefabs for them. Add spawner. And now we will actually not use the preview of a field designer window, but we will need a grid painter for these examples. So let's go to generators and grid painter. I will assign there our stairs setup field. Adjust the position. Paint few cells. Switch back to field designer window, clear spawned objects and use grid painter for our preview. And you see that I added the stair style without any rules, so it's just spawned here. We will fix it in a while, but first let's paint some cells in a stairs manner. And it will look like this. Just for clarity, if you don't see it, each cube is a cell, and right now cells are set like this. And we will use this cells structure to drive rules for generating connection like this. And I see I used the wrong tile, so let's switch it. Let's add stairs placer helper rule. And actually default settings are meeting our criteria. The blue cubes are identifying cells which are required to execute this rule. And you can freely change them by entering cells selector. But you can select these cells only in a 2D representation of a 3D space. So the small 3D view is just to preview what you are actually doing, but in a 2D grid you select in the cells you want to use. And you can switch view for the different 2D representations to adjust the cells structure you need it to. The second cell selector is also very important. since with our approach we need to remove floor or other objects which are in our target place for the stairs. So without using it, the floors are still here. And the last selector is very optional. It's dedicated for handling some exception situations. In case there is some cell present in a grid with which we want to prevent spawning this stairs module. Alright, now you can combine this stairs placer helper with any other rule, so we can just adjust the position to fit with our setup. But now let's say we don't want to make the stairs to be so steep per cell. And to solve this we can alternate the grid cell size to be shorter in the y-axis. So now instead 2 units, the height of one cell is 1 unit. And we can switch to this stairs prefab. But again, let's say we still want to have possibility to make the steep stairs. And to do this we would need to set cells like this. And you see our small step is not meeting criteria for this cell structure. So let's add another spawner with our step stairs. And let's add stairs placer helper and adjust its features to support our current cell structure. And is it working? Yeah, but the floor is still here, so let's remove the one more. And let's adjust the position. And there we have it. If you need more examples for the stairs rules, you can check the demo field setup, which is called fence tile set. It contains spawners with some more variations with the stairs. Okay, now let's go back to the build planner window. For the first time we will not notice it, but there is a problem. With a cell structure like this, you would need to provide many different stairs modules. And there you see why. To make stairs like this look properly, we would need to make modules for stairs up right, up left. And to avoid that, we can use another rules for the pathfind direction. Require direction continuity to prevent changing direction too soon. And require direction origination to require a back step in a defined direction to use this step. And now pathfinding algorithm will have really hard task to use these rules to generate path. But it will make it best to generate the path we need. Alright, and that was the most important subjects for the pathfinding algorithm. Now let's go to the final part of this tutorial. We will switch back to our first example. And let's say we want to have a lot of rooms. So as for now, let's increase the instances count to 16. And as you can see, if we want to generate path towards the main room from each other room, the result is kinda okay, but it's only because paths are merging together, making it possible to enter different rooms when entering one corridor, but with different layouts it can be much worse. So we will use a bit more elegant solution for it. So I will go back to our paths field and I will disconnect completely from our previous approach and prepare here a new one. I will use node called generate fields connections, and this node will automatically generate connections between all fields we will provide it in a way that if you are in one room, it's guaranteed that you can reach any other room we provided. Okay, for beginning we will get all instances of the other rooms, so let's use get field planner instances node. Let's get instances of our rooms and let's connect it to the who's from. And now we can call pathFindGenerateIn. I will quickly set the flat settings for the quick search, and the generate field connections node is providing us the fields we need to connect. Let's not forget about the collision check, so let's collect all fields from the layout. And now let's join the shape cells with our paths field, and let's check it. And as you can see, the connections are chosen pretty nicely, but it's lacking connection with the main room, so let's add it to the who's from group of a generate fields connection node. To group more fields, you can use the add node or connect multiple field wires to the input, but it will work only if the target node is supporting it. Okay, now the connection is generated. Let's check few more variations of this layout. Well, it works pretty well. As one of the last thing for this tutorial, let's check the step debug to follow what's going on step by step. And there you can see the preview of the possible connections made by generate fields connections node. And final step of this tutorial, we will just use our build plan and generate something with it. I will use the fence tile set. Okay, let's generate. And there we have some layout like this. Let's quickly use composition just to change color of the main room. Maybe this. And alright. That's all for this tutorial video. I hope it was useful for you. If you have some questions, feel free to ask in the comment section below. Hit a like, subscribe for more. Thank you for watching and see you next time. Bye bye.